A very good, a very good afternoon to all. My name is Munira. Let's begin with our second session of the day. This session was planned for Dr. B.J. Shah, sir, but due to unavoidable circumstances, he will be delivering his lecture in the third session. Now, this second session will be delivered by Dr. K.B. Parikh, coordinator of this FDP on repair and retrofitting of structures. I welcome him on behalf of the Government Engineering College, Dahod. He is working as the head of the Department of Applied Mechanics at Government Engineering College, Dahod. He completed his doctorate from Sardar Vallabhbhai Institute of Technology, Surat, and his master's and bachelorate from Bilra Vishwakarma Mahavidyalaya, Vallabhbhai Vidyanagar. He has teaching experience of over 20 years. He has published more than 67 technical papers in various national and international journals. Currently, he is guiding 5 PhD students and he has guided over 35 ME students. He has also organized many training programs and delivered expert lectures in various training programs. He has also received a research grant from Gujarat Gandhinagar and has been awarded by GTU Pedagogical Innovative Award in February 2015. Once again, I will warmly welcome Sir and request him to deliver this lecture. Thank you.
Thank you, Munira. Now, let us start with the presentation. I think the screen is visible. Okay. Let us start with the topic on the repair and retrofitting of structures. As this is a very basic and fundamental topic which has been selected right now over here, because this particular training which is related with the very fundamentals of the geotechnical as well as structural engineering aspects. Our second training will be on the advanced level, which will be started from the 30th August. So based on the approach, based on the view of the fundamentality, this topic which has been selected. Now, the question will arise in our mind, what is repair? So before I'm going to proceed with this session, the main objective is to share what is repair, what is rehabilitation, what is retrofitting, what are the techniques, that we have to deal with the repair as well as retrofitting, that we have to discuss. So repair is nothing but to bring back the position of the structure to its previous conditions. So it gives performance same as previously. So here the very important word, the performance word is there, but it doesn't deal with the word strength aspect. So if we are taking some examples of the repair, we may take the word decoration of the structures, like with the help of painting, whitewashing, maybe the wiring of building, maybe the replastering wherever it is required. The changing of flooring is also considered as a repairing technique, repair of the doors and windows. If we say the structure is concerned, then repair means the slightly peeling off the minor cracks. Also, the relaying the disturbed floor roof tiles are also treated as the word under the repair. Then the next terminology, what is rehabilitation? Rehabilitation of a building means returning a building or a structure to a useful state by means of maybe a repair, by means of a modification or an alteration which can be did in any kind of a structure. So it means that it is related with the strength aspect of the structures also. Means to bring back the position and the condition of the structure By considering the strength aspect, which is to be termed as known as rehabilitation. So here the terminology strength is also involved. The some of the examples of the rehabilitation means to fill the wide cracks using some suitable material. That material may be anything, maybe a mortar, maybe an epoxy, or any other material. Injecting the epoxy-like material into cracks in walls, columns, beams, etc. Now here the procedure which has been carried out is the removal of the damaged portion of the masonry and reconstructing it by using rich mortar mix, which is also treated as rehabilitation. Addition of reinforcing mesh on one side, maybe on the both side of the walls, which may enhance strength. Then that term which has been associated with that particular technique is known as rehabilitation. The third terminology is nothing but the retrofitting. Now, retrofitting term, which is more or less is associated with the damages causes to earthquake, or even though the damages which has not been taken care, but we want to improve the strength to mitigate the earthquake, then this retrofitting word which has been associated. So earthquake creates the greater devastation in terms of the life, money, and the failure of the structures. So for the longer time study of any kind of the structure, the earthquake mitigation study is very much important. Hence, it is very much necessary for the historical monuments to save it, also to save the human beings in the zone of the earthquakes, also to save the tall structures. So it is nothing but retrofitting, is nothing but the modification of the existing structures to make them more resistant to seismic activity, ground motion, or soil failure due to earthquakes. The retrofitting techniques are applicable also the other natural hazards like tropical cyclones, tornadoes, and severe winds from thunderstorms. So right now we are dealing with the retrofitting word with the earthquake, but even though the retrofit term which has been taken care with the also other natural hazards. So the question may arise in our mind, when is the seismic retrofitting needed? Under two different circumstances, the seismic retrofittings are needed. The one itself is earthquake damaged building, and second one is earthquake vulnerable building. Right now, the earthquake vulnerable building means there is a chances to create an earthquake, or because of that, the building will be going to affect. And another one is the building has already been affected. Some of the examples of the retrofitting are increasing the lateral strength in one or both directions by reinforcement or by increasing the wall areas or the numbers of walls and columns. We will detail discuss the retrofitting technique, the methodology. Here just enlisted the certain examples. Second one example is giving unity to the structures by providing proper connection between resisting elements. Definitely, because connection which has to be restored, then and then the structure will become stronger, because the element, particular the joint element, is the weakest link for any kind of the structure. Eliminating, the third example is the eliminating the features that are sources of weakness, asymmetrical blunt distribution of resisting members, abrupt change of the stiffness from one floor to the other floor. If these are there in the structure, it requires retrofitting, because at one place the stiffness is something different. From floor to floor, the stiffnesses are ghost shows, or maybe it may possible within the floor itself the stiffness are different. Another reason, another example is avoiding the possibility of the brittle modes of the failure by proper reinforcement and connection of the resisting member. So now, if we come back to the repair, when the repair is required, when the structure which is subjected to the corrosion, carbonation effect, sulfate attack, salt weathering, alkali aggregate reactivity, cracking of concrete. But here the important is the minor effect of cracking is there, but it is a minor effect. If it is a major cracking, then we have to go either rehabilitation or we can go for retrofitting. Another is the acid attack, maybe the damage attack to the fire, maybe the attack due to microorganisms. So these are the reasons, these are the cases where the repairs of any kind of the structure is or the structural component is required. Now, repair procedure or the methodology with very vast conditions is there. The first is the preparation. For any repair procedure, we have to carry out certain investigation, the preliminary investigation which is to be required. We have to make a first of all detailed plan about the repair, where, when, which kind of technique. So the primary investigation and detailed investigations are the main component for the repair procedure and methodology. Where in detailed investigation, the data collection, field measurement, condition survey, sample collection, testing of samples, etc., etc., to be required. And finally, the conclusion and recommendations. With this conclusion and recommendations, we can proceed further. Repair methods. There are certain repair methods. The first is deals with the masonry structure. If we deal with the masonry structures, then there will be a pinning for arch ring separation is one of the conditions where the repair is to be required. Then concrete fill of the spandrel walls, and the third one is the crack injections where the repair is to be required. While in case of the concrete structures, the surface protection, protection of the steel reinforcement are the conditions where the repair is required. While for the steel structure, the repair for the under corrosion or maybe the cracks or maybe distortion where the repair is to be needed. There are structural cracks that let us discuss about the structural cracks. The structural cracks may occur due to what are the reasons, what are the circumstances under which the cracks will occur. The first one is the defective design and defective load assumption under which the structural crack may occur. Obviously, there are certain assumptions given in the codal provisions. We have interpreted something and taken certain wrong data under which the load will come higher side. And because of that, the structural cracks will be there. It also possibility that will be a perception in the behavior of the structure. The behavior may go change because of maybe the higher load or maybe the change in the user conditions. The another reason is incorrect assessment of the bearing capacity of foundation soil and the soil property. So this is the another way where the structural cracks will be there. The third is the defective detailing of the joints of components like roof with brick wall corner joints or walls. Another reason, the defective detailing of the structural steel reinforcement. And last but not the least, the lack of the quality control during constructions which leads the structural cracks. If it deals once again higher side in detailed depth, the structural cracks may be because of incorrect design, faulty construction, overloading. We have constructed the building because of certain reason, but because of we are changing its usage, then maybe the overloading conditions may create the structural cracks. It may be possible that the particular structure which has been created for particular industry purpose and the industry move those changes, and because of the loading criteria those changes. The non-structural cracks will be generated because of the moisture changes, because of the environmental conditions, thermal movement, also maybe the elastic deformation, maybe the creep and sinkage of the concrete itself, maybe the use of the aggregate, maybe the use of the sand, the typical sand that came from the site, maybe the chemical reaction, maybe the foundation movement and settlement of the soil, and also the vegetation may create the effect of the cracks. Non-structural cracks, The first one is the moisture changes. Building material expand on absorbing moistures and shrink on drying, and these are the general behavior. And because of that, the shrinkage in concrete and the mortar expands or depends on the numbers of factors. The first one is the cement concrete, another is water content, and third is the aggregate. So richer the mix, greater is the drying shrinkage. More is the water in the mix induces also the greater shrinkage. And also the large aggregates with the good grading, which has a lesser shrinkage for the same workability as less water is used. So these are the certain conditions where that will affect the shrinkage, and this leads to shrinkage cracks. Curing definitely affect also the is not properly cured. So if proper curing starts, the initial set has been taken place and continued for the 7 to 10 days, the shrinkage is comparatively avoidable. Excessive fines, if in concrete the finer particles are excessive, then aggregates require more water for the same workability, which leads more shrinkage. Environmental effect, temperature. Concrete made in the hot weather needs more water for the same workability, results in more shrinkage. Material used or materials for the crack repair generally are of the cement slurry, maybe of cement mortar, maybe of epoxy resin, maybe of PNC product, that is the polymer modified cementitious products, which are to be used for the crack repair. Now for the crack repair, in order to determine whether the cracks are active or dormant, means it is inactive, we have to carry out certain basic visualization, namely investigation, periodic observation, which has to be carried out. By placing the mark at the end of the crack, or a pin or toothpick which is lightly wedged into the crack, and it falls out if there is any extension of the defect. It means that the crack is there in the structure. We have to put a mark on both the sides of the crack, and periodically observations we have to be carried out. If that mark will be extended out, there will be an active crack, and if it remains same, it is inactive crack. Now a strip of the nose tap work similarly, that is here the movement is indicated by clearing of the tap. If you would like to see the image over here, the figure number C, it is the nose tap is there, which is visualized over here, the tap which is associated throughout the crack. If the crack will be elongated, if the crack is active, then this particular tap will be cleared off, and it will be measured that the particular crack is active. Then the device using the typical vernier caliper, which is also to be used, and it also gives a satisfactory results. Also the extensiometer can also to be used for the accurate reading. Also some cases we require the extreme accuracy, then we can use the resistance strain gauges to measure whether the crack is active or dormant. There are the certain images which are shown over here. Crack repair techniques, we have to understand slightly detailed depth regarding this. The first one is epoxy injection grouting, is one of the crack repair technique. Then second one is routing and sealing, flexible sealing, stitching. The next is the providing additional reinforcement, drilling and plugging, the stressing steel, grouting, dry packing, surface coating. If I can enlist more over here, the more techniques can be involved. That depends on the location, that depends on the site. Also, it depends on locality to locality. The repair techniques are there, still they are there. These are the major techniques are to be enlisted over here that we have to understand over here. The first one starts with the epoxy injection grouting. When the cracks as narrow as 0.05 mm that can be bonded by the injection of epoxy. The technique generally consists of establishing entry and venting ports at the close interval along the cracks, sealing the crack on the exposed surface, and injecting the epoxy under pressure. This epoxy injection, which has been successfully used in the repair of the cracks in the building or any kind of the structure. Now, the general procedure will be enlisted over here. Before I'm going ahead, let me show one small video so that you can understand better way, and then we will discuss over here. I think, is it visible? So now you just see over here, if I'm muting the down. So hello, now you just see over here, there will be a machine is there, taking the epoxy over here and then filling out the crack. See the arrangement, the crack which has been filled by this particular pot. At each and every crack, at certain distance, the pot which has been kept it out. See, so they are filling the crack. You just wish you see the cracks which has been filled out by the epoxy, as it's the fluid which has been moved from one place to another place. I think the PPT is visible. Fine. So now, after looking this video, let us try to understand what will be the procedure which has to be done by using this approach. The first step is to clean the cracks that have been contaminated. That is to extent that is possible and practical. Why? Because the cleaning is the first step. If there will be certain debris, then it is difficult to join the particles. So this contamination, like the oil, grease, dirt, and the fine particles of the concrete, which will prevent the epoxy penetration and the bonding, and which will reduce the effectiveness of the repairs. And hence, because of that, we have to first of all remove that one. That removal of the contamination should be done by the vacuuming or flushing with water or any other special effective cleaning situation of the solution can be carried out. Then allow the surface to dry. Seal the surface, the cracks between the injection points. Inject the epoxy until it flows out to the adjacent sections of the crack or begins to bulge out the surface seals, as you have seen in the video. In this case, if you require, you can use the hydraulic pumps or certain paint pressure pots to be used to inject the epoxy. The pressure used for the injection must be selected carefully because pressure will be high, there will be the overflow of the material. If the pressure will be low, it is difficult for the penetration or the use of epoxy into the crack. So as increase the pressure often does little to accelerate the rate of injection. So if the crack is vertical or inclined, the injection process should begin by pumping epoxy into the entry port of the lowest elevation until the epoxy level reaches the exit port above. So from starting from bottom to the top if the crack is vertical. And for the horizontal cracks, the injection should be proceeded from one end to the another end with the same approach. If the pressure cannot be maintained, the epoxy is still flowing into the unfilled portion or leaking out of the crack to be done. Usually, the epoxy is injected through the holes of about 3 by 4 inch in diameter, and the 3x4 should be at 6 to 12 inches at the center. So the spacing is also to be maintained properly. And the smaller spacing is to be required for the finer cracks. So after injected epoxy, which has to be cured, and surfaces should be removed by grinding and other means as appropriate. The limitation of this method is that unless the crack is dormant, that is active, or the cause of cracking is removed, thereby the crack is dormant and it will be probably recured. So if there will be dormant crack, then this method is not that much viable. Also, this technique is not applicable if the defects are actively leaking to the extent they cannot be dried out or where the cracks are numerous. This particular technique is not useful. See the images. As we have seen the videos, it will be clear to all of you. There are certain other images which shows the failing of the epoxy by using the injection. The second is method for the repair is routing and sealing. The two terms is involved over here, route and seal. Question may arise, what is the word route means itself? Routing means nothing but enlarging the crack. We have to expose the face of crack. It is nothing but the routing. And seal means together the sealing process. So this method is nothing but the enlarging slightly the exposed face of the crack and then carry out the sealing process. This is known as the routing and sealing. So this can be used in the conditions requiring remedial repair or when the structural repair is not necessary. This method involves enlarging the crack along its exposed face called chasing or routing and filling and sealing it with a suitable material which is called sealing. This is more advisable method to the flat horizontal surfaces such as floors and pavements, even though it will be certain times applicable for the vertical surfaces as well as on the curved surface also. This is a method where thorough water tightness of the joint is not required or where the appearance is not important. The routing and the sealing procedure can be done. Here the sealant may be several materials including epoxies, silicones, polysulfides, polymer mortar, or anything can be used over here. The basic procedure involved in this case is the preparing the groove at the surface ranging in the depth typically from 6 to 25. This groove is then cleaned and allowed to dry. Then sealant is to be placed into dry groove and it is to be allowed to cure. You see the image, the basic original crack is there. We have to do a routing process like the widening in the surface and then the joint sealer which is to be used over here. The detailed image which has been shown over here. Now let us see one smaller video over here. I think it is visible. I wish it is to be understandable easily how to use this procedure. At least kindly request you to check whether voice will be there or not. Check once again. Now, the third repair technique is the stitching. We use this word of stitching generally in case of the clothes when there will be a tearing of a clothes, the stitching which has been carried out, or it may be the stitching word which is associated in the medical term. If there will be something will be happen to our body, then the stitching will be carried out by a doctor. Similar the stitching over here, that let us understand the word. What is the stitching in terms of the repairing technical sense? The stitching procedure consisting of the drilling holes on both the sides of the cracks and the cleaning the holes. Then anchoring the legs of the stitching dogs, then span the crack. Then either a non-stick ground or a epoxy resin based on the bonding system. So here also we can use just like a clips-like system to apply the stitching process. Concrete can be stitched by iron or the steel dogs. Right now, certainly advanced terminology, the people are using the FRP rod are also using for the stitching. So a series of stitches of the different or variable lengths and the orientation or both should be located. Then the tension transmitted across the crack is not applied a single plane but the spread over area. So here we have to go for a bend bar into the shape of a broad flat bottom little U between the 1 foot and the 3 feet long, and which ends about the 6 inches long. So the figure clearly indicated. Here you just see that the crack is there, and the non-variable length as well as the location and the orientation of the staples, so that the tension across the crack is distributed in the concrete rather than the concentrated at single plane. So it is not necessary that the half of the portion on the one side of the crack and the half of the other side. You can make the changeable length may possible, and this stapling which has been done by carrying out the hole by the outside. So this hole will be filled by lastly by the epoxy. So this procedure, which is referred as the stitching process. Let us see one small video based on the stitching process. I wish the voice will be there. Voice will be there. Please check it out. The voice. It has been some complaint that there is no voice, so would like to once again screen sharing done by myself. So now check it out the audio. The voice is not there. Why? Please check once again. Why voice is not there? So it is the window. Oh,
Entire screen. So what do you want to spend it?
so there is super instances. So we got I think some of the message has been received that there is no voice from the video. We are trying our best to sort out these issues. This had to show the stitching procedure. Now, the repairing of the crack by the external stressing by means of the pre-stressing steel. So here the application of the pre-stressing steel for the repairing condition which has to be used. So when there is a major portion of a member is to be strengthened, post-tensioning is often desirable solution. So here in this technique, the cracks can be closed by inducing a compressive force because cracks will be generated because of the tensile force. So the opposite to that, the compressive force which has to be generated by applying a pre-stressing steel, which is sufficient to overcome the tension and to provide a residual compression. So here the principle is very similar for the stitching. Except that the stitches are tensioned rather than the plain bar dogs which is applying no closing force to the crack. Here in this technique uses the pre-stressing strands or bars to apply compressive force. So some form of the abutment is also needed for providing an anchorage for the pre-stressing wires of road as shown in this image. Here in this particular first figure you can visualize that if we crack is there and we have to apply this tension tie over here that will create the compressive force to close the crack. See the another image for the same approach to force and fundamental. The actual image which has been shown over here. Now external pre-stressing, here can we visualize that the pre-stressing tendons are placed on the outside of the physical cross section of the force which are to be exerted by pre-stressing tendons are only transferred to the structure at the anchorages and at the deflectors. External post-tensioning can be used to improve the performance of any kind of the beam bridge like timber, reinforced concrete, pre-stressed concrete, steel, or composite. Another repair technique that is we discussed about the grouting. Grouting is a process of injecting the mixtures of cement, sand, water at the high pressure in the cracks, joints, voids, etc. This has been done, which is the same manner as of the injection of an epoxy. But here the grouting can be carried out with any kind of the material. Not only the epoxy, you can use the cement paste also. So first of all, they clean the concrete along the crack, then install built-up sets at interval along the crack, seal the crack between the seats with a cement point or grout, and lastly, flush the crack to clean it, test the seal, and grout the hole, and finally inspect the crack at the last stage for a long time period. Now, the basic purpose of grouting is to strengthen the porous concrete, to prevent the seepage in dam and the water structure, to reduce the uplift pressure below the dam, and to fill the cracks in concrete structure. one of the image before grouting and after the image after the grouting. Now, this detailed procedure of the grouting followed by the following ways. The first is the drilling of grouting holes. That is, to apply the grouting, we have to carry out certain holes with certain strategy. For drilling grouting holes, equipments like the jackhammer, diamond drill, short drill, etc. to be used, and the choice of the type of the drilling equipment depends upon the type of stone, size of hole, depth of hole, etc. Then arrange the grout pipes. Grout pipes of the 4 to 5 centimeter dia, 40 to 90 centimeter length are inserted into the grout holes, and the space surrounding the pipe is filled with the help of a cement mortar. The top end of the pipe is connected to the pump. Finally, the cleaning of the cracks which is to be required before injecting the grout mixture so that the proper bond which can be carried out. Then we have to insert the grout into the holes with certain pressure, specifically 0.65 kg per cm square per meter depth hole. There are certain types of grouting. The one is the consolidation grouting, second is the stage grouting, third is the curtain grouting. This consolidation grouting, which is used for the shallow depth grouting holes, normally at a pressure below 3 kg per centimeter square, which is also known as low pressure grouting. While stage grouting, here it is to be required when the thick layers are to be grouted. The total thickness of the layer is divided into the stages of 1 meter each, and grouting of each layer is to be carried out one by one. Here, the grouting of the upper layer, which is started only after the grout in the lower layer had properly set. The third one is the curtain grouting. This type of grouting is done to prevent the seepage of water below the foundation of dam. Grouting holes are drilled in the upstream side of the dam in the bedrock, and impermeable grout wall is to be created to prevent the seepage of water from the dam foundation. Now, based on the grouting material, there are also three methods: the Portland cement grouting, chemical grouting, and the epoxy grouting, depending upon the material to be used. If we are using the Portland cement grouting, certain procedure that we have to follow. The first one is the widen the cracks, particularly in the gravity dams as well as thick walls, which may be repaired by filling the Portland cement ground. This method is effective in preventing the water leakage, but will not structurally bond cracking sections. Here, the procedure is the same as the cleaning. First of all, the concrete along the crack by air jetting, by water jetting, then installing grout at the suitable intervals, and after that we have to sealing the cracks between the seals with the sealant and flushing the cracks to clean it. So after doing the application of the grout, the test of the shoe to be done, and then grouting the whole can be carried out. The grout mixtures is nothing but the cement plus water or cement plus sand plus water, and this depends on the width of the crack. Water reducers or the admixtures can be used to improve the property of the grout. For the large volumes, a pump may be used, and for the small volumes, a manual injection gun may be used. See the image of the figure, which is clearly showing the grouting procedure. Chemical grouting, which can be used for grouting using the sodium silicates, maybe urethanes as the elements. Two or more chemicals are also combined to form a gel, as opposed to the cement grouts consisting of the suspension of the solid particles in the fluid. The advantage of the chemical grout that can be applicable in the moist environment. Also, this chemical grouting can be applied in very fine cracks. See the image here, the chemical grout which is to be used over here. The next procedure, that is nothing but the blanketing. The term itself understands blanketing, which is used for the mode of repair. It is similar to the routing and sealing, which is used in a larger scale and applicable for sealing active as well as inactive cracks open. Here, the first step is to carry out the routing. That is, making the chase is the first step. Usually, this chase or the routing is to be done in a cut square shape instead of a V groove that we did in case of routing and sailing here, which has been done by the cut square. The bottom should be chipped as smooth to facilitate the breaking the bond between the sealant and concrete. If you see the figure here, it should be a square or maybe the below chase which has been done over here instead of V groove. The sides of the chase should be prepared to provide a good bond with the sealant material. The first consideration in the selection of the sealant material is to amount of the movement anticipated and the extremes of the temperature at which such movement will occur. So there are 4 types of the blanketing joints. The type 1 which can be used for the elastic sealant, type 2 for the mastic sealants, type 3 is a mortar plug joints, and this research is filled by the mortar, while the water-equipped bar used as a type 4. See the images. The sealed face which can be sealed chase which can be shown over here. It's nothing but a rectangular portion which can be filled by the sealant. The next technique for the repair is nothing but the overlays. Overlays may be used to restore a swelling or the disintegrated surface or to protect the existing concrete from the attack of aggressive agents. Overlays used for this purpose to include the concrete or mortar, bituminous compound, etc. Overlays is nothing but the spreading of something on the bigger area. Here, the epoxy should be used to bond the overlays to the existing concrete surface. Overlay is used to seal cracks. Overlays are also used when a large number of cracks are there. Fitting each crack is expensive. For active cracks, overlay is done with the material which are extensible but not flexible, like polymeric membrane with the top coat of tar. For the inactive cracks, any type of the overlays may be used, like polymer modified Portland cement mortar or concrete or by silica film concrete. Accordingly, an overlay which is flexible but not extensible can bend but cannot be stretched, will not seal a crack that is active. Here, the gravel is typically used for the roofs, for the overlays, and the concrete or brick are used when the fill is to be placed in the overlay. An asphalt block pavement also works well where the area is subject to the heavy traffic for the overlay is concerned. Another method to use repair is nothing but the drilling and plugging through cracks. This technique is only applicable when the cracks run in reasonable straight lines and are accessible at one end. This method is mostly used for repairing of the vertical cracks in the retaining wall. One of the appropriate methods that to drill the holes normal to the crack, fill them with the suitable epoxy or epoxy mortar formulation, and then place reinforcement bars of the predetermined size and length in them and then stitch across the cracks. Here the bars will be placed in the clean holes prior to filling the epoxy, but then great care is to be needed not to entrap any air so that then effectively repair can be carried out. Here, a hole typically of 50 to 75 mm in diameter should be drilled, centered on hand following the crack. If you visualize the figure, centrally a hole which has been carried out in this figure image, that of 50 to 60 mm minimum diameter into the stem. Now, this hole must be large enough to intersect the crack along the full length and provide enough repair material to structurally take the load exerted onto the key. The drilled hole should then be cleaned, made tight, and filled with the grout. The grout key prevents transverse movement of the sections of the concrete adjacent to the crack. Here, the key will also reduce the heavy leakage through the crack and loss of the soil from behind the leaking wall. Water tightness is one of the important criteria over here, and the structural load transfer is not. The drilled hole should be filled with the resilient material of the low modulus of elasticity. Here, the key effect is essential, and the resilient material can be placed in the second hole to fulfill the grounded, as shown in the particular figure. Now, for any kind of the repair, after doing that, the long-term monitoring strategy is very much important to see the effectiveness of the repair. This long-term monitoring strategy may be in terms of the visual inspection, maybe to carry out the debonding, because visual inspection is to be needed because finally at certain stage the debonding can be observed after certain time. We have to also monitor in this visual inspection the effectiveness of the entering of the chloride content, maybe the moisture content. It is also at most necessary in this long-term monitoring about the measurement of the carbonation depth. And the reinforcement corrosion assessment should be required in the long-term monitoring. Now, after doing the repairing condition, let me proceed further the retrofitting. What is retrofitting? What are the retrofitting techniques are there? And how it will be useful to us for which kind of conditions that we have to understand. Now, as per IS 13935, retrofitting is nothing but to upgrade the earthquake resistance up to the level of the present day by appropriate techniques. Newman in 2001 gave a definition that retrofitting is an upgrading certain building systems such as mechanical, electrical, or structural to improve performance, function, or appearance. Means that retrofitting is nothing but the structural strengthening of a building, whether or not an earthquake has occurred. What is the need for retrofitting? The first one is existing weak, unsafe building which is required for the retrofitting. Building not designed to as per the codes which is needed for the retrofitting to enhance the load carrying capacity, to catch up the load carrying capacity against the earthquake. Upgrading of code based on the seismic design forces. Upgrading the seismic zone, as the seismic goes to just in one place, which is before it is in zone 3, now it is in zone 4. Based on the surging seismic activity, needed the retrofitting. The relation of strength on aging of the structure also needed the retrofitting. Modification of the existing structure affecting its strength adversely need retrofitting. Changes in the use of the building, increasing the floor loads, which also needed the retrofitting. Higher cost of the rebuilding than that of the strengthening or retrofitting, which negate the retrofitting. There are the certain various reasons are there for the retrofitting, maybe the more than this which is enlisted over here. Now, here the one image shows that clearly. Here the first graph shows the P versus delta curve, loads versus deflection curve, or you may say the moment versus theta curve, rotation curve. Here it will be clearly visualized that the existing structure and its displacement and the retrofitted structure and its displacement versus load carrying capacity. So you can see that there will be a drastic increase in strength will be there after retrofitting technique. There will be increase in the ductility also involved because of the application of retrofitting, and increase in the stiffness can be observed because of the retrofitting technique. Another figure shows the energy dissipation capacity of the retrofitted structure versus the existing structure. So graph is nothing but the energy versus time. The full line shows the retrofitted structure and dotted line shows the existing structure. So energy dissipation capacity is also enhanced for the retrofitted structure in comparison with the existing structure. This image clearly shows the permanent deformation control of retrofitted structure versus existing structure. In the dotted line, which is clearly shows that there is certain permanent deformation will remain in the structure, in the existing structure, but when you apply the retrofitted structure, that permanent deformation is very, very negligible. So these are the advantages of application of the proper retrofitting technique to be applied. Now, there are certain steps of the retrofitting to be needed. The first one is the evaluation. Evaluation is the major and the important step for any structure to be there, and in which the first step is the structure analysis. The analysis of any structure, existing structure, should be carried out by the linear static or dynamic, maybe non-linear static or non-linear dynamic. Any method which has to be applied depending on the type of the structure, category of the structure, and need of the structure, the method to be involved. And after carry out this one, it is to be find out what are the deficiency involved in the retrofitting, and then the decision of the retrofitting has to be carried out. The selection and the design of the retrofitting strategy which has been adopted after that by doing the design, taking the design strategy. Then verification of the retrofitting strategy which has to be done, and once again do the structural analysis by using the applied retrofitted structure. Then we have to go for the construction side, that is application of the retrofitting strategy, and finally is the monitoring of that particular structure after application of the retrofitting. Now, as per IS 1893, it has been stated that there are certain attributes to be required for the better performance, so that the effect of the earthquake can be avoided and we can achieve the adequate lateral strength, stiffness, ductility, and integral action, which can be achieved by simple and regular configuration for a structure. Now, there are certain basic solutions which can be enlisted over here in detail depth, but majorly contributed into the three types. The first is the application of new shear wall into the existing structure to carry out the drift control, to solve the irregularity issues, and to solve the new code provisions. The another one solution is nothing but the steel application of the steel bracings. It is very much effective specifically for retrofitting technique is concerned to dissipate the earthquake energy. But here, an important thing is that the connection is a crucial criteria between the abrasion and the concrete. Third one, retrofitting solution is jacketing. Jacketing may be carried out with the help of steel, maybe with the help of the reinforced concrete, and with the help of the fiber reinforced concrete. Here we can also apply the jacketing with the help of the FRP fiber reinforced polymer sheet. This will increase the drastic strength for that particular component or a joint. Generally, the retrofitting techniques can be bifurcated into the two types. One is global retrofitting technique, another is the retrofitting technique local. Now, global retrofitting technique means which is applicable for the whole structure, and local retrofitting technique means which is applicable to the specific structural component. So, if we say that for the global retrofitting technique, the one approach is the adding of new shear wall, adding of infill wall, adding of bracing, adding of wing wall or buttress, carry out the wall widening or wall thickening, or maybe reduction of the mass, or maybe the application of any damping or base isolation. This will be have to carry out for considering as a whole structure. For local retrofitting technique, it can be used as jacketing of beams or column or beam column joint, or strengthening or jacketing which has been carried out as an individual footing. So this is nothing but the different retrofitting technique. Now let us go with the first one, which is the jacketing. What is jacketing? How it has to be applied on the structure? This we discuss over here. It is the most popular method for strengthening of the building columns, and at the site, it is the more structural engineering are preferred the jacketing as a technique for retrofitting structure, retrofitting of a column or maybe a beam. The purpose of jacketing that it increase the concrete confinement, and this concrete confinement may increase the shear strength as well as the flexural strength of the component of the structure. This will also increase the strength and ductility. Here, a most important thing is that there will be an adequate connection is to be needed for new and old concrete. Here, the additional longitudinal bars, which is to be continuously through the slab and to be anchored to the foundation. Here, the replacement of the old bar which has to be carried out. Here, the additional ties which has to be kept as per the seismic detail. Here, there are some of the images shows clearly about the jacketing is there. The first one we will go with the column jacketing. So before I proceed and explain the column jacketing, let us proceed with the one small shorter video so that we can understand very well the column jacketing. There will be one video is there for the overlays, but let me start with the column jacketing. Before I can proceed with the column jacketing, I have to check the voice over there. Here there will be a systematic procedure which has been explained for the jacketing. Just see very carefully. Another video, please show the column jacketing. Now you just see over here in this video, the holes will be provided throughout the slab. So the reinforcement is constantly provided from the bottom part of the slab to the top part of the slab. So there will be continuous reinforcement which has been provided. And this reinforcement which has been provided finally with the help of epoxy grouting which has been done at the pole. The another thing is that you just visualize over here this reinforcement. Specifically this U shape, actually this also has to be inserted inside the concrete. It is nothing but a key. The function of the key, this shape, U shape which has been there, the function of that, I think my voice is clear. Hello, my voice is clear? Okay. So here it has been shown that the function of key is not only put up the reinforcement together, but it creates the bonding between the old concrete and the new concrete also. So it's just only not the function of that one. See the various places the key which has been inserted, and the reinforcement is not to be put anywhere. It has been provided throughout the slab. So intention of this show the video is the same as the more or less previous one, but to show nothing but a key portion, the key which has been applied over here. Now let us proceed further with this, the presentation. Is it visible presentation? Okay. Now, the column jacketing is done to improve the load carrying capacity of the column, and the basic procedure is open the footing of the column by excavating soil, ground it, remove the plasters from the surface of the column, make the surface of the column concrete rough by sand blasting, remove the corroded bars by cutting them, add new bars from the footing to the slab as per the design requirement, and provide the shear key. As I stated, the word shear key which has been shown on the video part. Apply the bonding agent on the old concrete for proper bonding between the old and new concrete. Then apply concreting as per the design requirement. The shear key which has been shown in the image, you have also seen in the video. Where it is to be provided, it is to be, first of all, we have to provide a drill holes to the specified diameter and depth to receive a shear key. Clean the drill hole by blowing the air. Inject the epoxy bonding paste in the drill holes to fill it from the ends to half the holes. insert the L-shaped shear key and allow epoxy to cure. What are the functions of shear key? It bonds properly new concrete and old concrete. It holds the main reinforcement in position so that there will be a monolithic construction of the column can be done. Here, because of the shear key, the whole section will become an effective. It also resists the shear failure. It improves the shear resistance of the column. It reduces the sliding effect between the new and old column. There are certain images for the jacketing of the column as well as the foundation together, which has been shown over here. Frequently, one term I'm going to use: provide the reinforcement throughout the slab, not to cut the reinforcement near the column. Now, another image is for the typical column jacketing. Now, bonding agent used. It is needed to properly bond between the new concrete with the old concrete so as the bonding agent should be applied to surface of old concrete before casting of the new concrete. Generally, epoxy bonding paste is used as a bonding agent. This bonding agent is not only bond the old concrete with the new, but also creates the whole section effective. Admixture used. Here, a hyperplasticizer admixture is used with the new concrete to increase the strength and workability. The function of admixture is to create the concrete flowable, to eliminate the difficulty of vibration, to increase the strength of the new concrete. Another one is the steel jacketing. The jacketing is the same phenomenon that has been done neither in case of the concrete jacketing or the steel jacketing. Here the material which has been changed and we are using the steel jacketing. So before I'm going to proceed further, let us see one small video related to this steel jacketing. I think it is visible. Is it visible? Video? Now let us understand what is steel jacketing after looking to the video. So now there will be the doubt maybe in your mind which has been cleared. What is steel jacketing? Here the jacketing process which has been carried out by inscribing the column with the steel plates and filling the gap with the non-shrink ground. This provides a passive confinement to the core concrete. Its resistance in action and hook direction, which can be excellent. The main advantage of the steel jacketing is it does not significant weight to the structure, but with the concrete, but also save the curing time. But the disadvantages of this method is require heavy equipment to handle and maintenance, which is more difficult. Since the steel jacket is vulnerable to corrosion and impact with the floating materials, it is not to be used for the columns in river, lake, and seas. There are the certain images which is clearly shows over here the use of the steel jacketing. Now next is the beam jacketing. We have seen the column jacketing. Similar way, the same fashion, the beam jacketing which has to be carried out. To increase the strength, beam jacketing has to be carried out. The basic procedure was the same as the column jacketing. The surface of the old concrete is cleaned by air jetting so that any of the debris is that can be removed. Expanded the wire mesh is fixed on the two sides and the bottom of the beam, or as per the design requirement, apply the additional reinforcement. To ensure the good bond between the old and the new concrete, an epoxy bond coat is to be applied to the old concrete surface. And finally, the concreting can be carried out as per the design. See the images or the figure. The original size of the beam will be section will be enhanced by carrying out the jacketing procedure. Next is some other noise is there. Nirav, condenser, please see. Some other voice is there. Some interruptions is there.
It is clear, sir.
Okay. Use of bracings as a retrofitting technique. Some other voice is also there. Condenser.
I think
Fan voice is there. I think you just remove your one, sir. Probability. Okay. Now, use of bracings as retrofitting. The use of steel bracing system for strengthening or retrofitting seismically inadequate reinforced concrete frames is a viable solution for enhancing earthquake resistance. This bracing system reduces the bending moment and shear forces in the columns, so the lateral load is transferred to the foundation through axial action. Here, the total weight of the existing structure will not change significantly after the application of the bracing. The steel bracing, which is economical, easy to erect, occupies less space, which has flexibility designed for meeting the required strength and stiffness. But one of the drawback is the connection between the steel bracing with the concrete. The bracing system improves not only the lateral stiffness and the strength capacity, but also the displacement capacity of the structure. See the images over here that the bracing technique can be used for the retrofitting of the structure. Beam column joint strengthening. We have seen the beam jacketing, we have seen the column jacketing. Now the beam column joint is the weakening part for the earthquake load is concerned, for the seismic region is concerned. So here the beam column joint jacketing can also be carried out. So since the construction material have a limited strength, joint have a limited force carrying capacity, so when the force larger than this applied during earthquake, joints are severely damaged. So repairing of damaged joint, which is difficult, so the damage must be avoided. So beam column joint must be designed to resist the earthquake effect. Now, for beam column joint, maybe the concrete jacketing can be used, maybe steel jacketing can be used, and another one is the FRP wrapping jacketing. Fiber reinforced polymer wrapping jacketing can be carried out. See some of the images which can be shown over here, which is used for the beam column joint. The first one is the concrete jacketing. Another one which is used is the steel jacketing for a beam column joint, and use of the FRP jacketing may be used for a column, for a beam, or maybe with the beam column joint is concerned. So now, in retrofitting technique, let us we go. What is FRP and how the FRP can be used for the jacketing purpose? Before I proceed further, for the beam column joint or maybe a composite material, this will look like a very small video so that we can understand very well about the FRP jacketing. So step number one, it has been seen that the step number one is the surface preparation. Surface preparation is the main parameter for application of the FRP. So first of all, remove the debris is important one. Make out the surface clean. Make the round the corners so that the sharpened edge will not be effective for the application of FRP, so that the air will be entered inside. So we have to see that we make some round corners. Then application of the priming. Fill the bug holes if it will be there. So now you can see over here, after preparing the surface, they have filled the holes. Then they have applied the first is the primer. After application of the primer means to carry out a certain environment for the FRP to apply on a beam, maybe apply at a joint, maybe apply on a column. So it creates a certain favorable environment for the application of FRP. Then apply the sheet of FRP over here on that particular component, and then apply the saturant so that it will be attached to the concrete. Now, another video will be shown later on, but let us start what is exactly the FRP. It is nothing but a composite material. It is a material which is created by the combination of two or more materials on a microscopic scale to form a new and useful material with enhanced properties that are superior to those of the individual constituent alone. So which has been FRP actually made up of the two materials. One is the fibers having a weightage of 50% to 65%. The main function is to carry out the load in the design directions. These fibers are being the main load carrying constituent which gives FRP its strength. While second one is the polymer resin matrix, having a less load carrying capacity resin, but which is act as a medium to transfer the stresses between the adjoining fibers due to the adhesion. It also provides the protection for the material from UV ultraviolet rays and chemical damage. So FRP is basically made up of the two materials as shown in this visualized. Fibers provide the strength and stiffness. The examples are carbon fibers, maybe glass fibers, maybe the aramid fibers. Whereas the matrix, which protects and transfers the load between the fibers, maybe epoxy matrix, maybe polyester matrix, maybe polyester matrix. And combination of this two composite is known as the FRP material, which creates the material with attributes superior to either component alone. So if we are using the fibers alone, if we are using the matrix alone, having no use, but if we combine together, it will become a new composite material, FRP. There is certain application procedure. The first one is remove all unsound concrete and loose particles, arrest the corrosion, make it its original shape, grind the corner, make the surface smooth and undulation free, and then apply the adhesive. First is the primer, apply the FRP, and then apply saturant, that is base plus hardener, and then is the final applied product you can etch it. Then press the wrap strip by the hand, use roller to remove the air, put another coat of adhesive, and finally apply the protective coatings. This is nothing but the application procedure of the FRP as a retrofitting technique. So step number one, which has been shown over here in the image, that is nothing but the surface preparation. The surface preparation has been done by removal of the maintenance, removal of the paints, debris, curing compounds, etc. by sandblasting or by any other means of the technique. Another, the way of approach of surface preparations, which has been shown on the images. Then the grinding, the round corners which has been carried out of a specified radius. Why the rounding corner which has been carried out? So that the stress concentration which has not been done, when there will be FRP which is to be applied. Also, then there should be not any kind of edge being trained inside to the FRP. Another approach of the surface preparation means the fill bug holes, pinholes, honeycombs, voids. Means the repairing of the imperfection is to be required, and we have to create an even surface. Then apply the priming to subtract application of the first layer of chemical onto the surface. Then there are two types of the application of FRP. One is the manual weight, another is automated weight, and third one is manual dry. So what is automated weight? The FRP and the saturant which has been combined in the factory itself, and that FRP we have to just put on the concrete surface. Well, manual weight means manual application of the hardener, which has been done onto the FRP and then which has been applied on the surface. Similar for the manual dry. Application of FRP on the different component. The first one which has been shown, the image of the glass, as the color itself shows, it is glass fibers are there involved in the GFRP, and the black color shows it is CFRP. It's also the same thing application. Removal of the voids which can be carried out. This is the final finished product, and if you go for the coatings, for the aesthetic look, for the UV protection, for the heat protection, you can apply the coatings also. So this is nothing but the whole procedure for the application of FRP for the retrofitting technique is concerned. Before I proceed further, let us show one also video related to surface channeling. surface preparation which has already been done. They are going for application of priming. Then application of the FRP sheet to see over here. And then once again on the FRP, there has been applied the final hardener over here. Next, another video for the repair of strong column. Corner of the column which has been cutted down, then apply the additional reinforcement at that particular places, and then application of the FRP so that the column which will become as a circular one. We just show the image, and then the filling inside by using the regular material which is the concrete. So the way of application of the FRP is also shown in this way also. The another one, the retrofitting technique, is nothing but the application of RC structure wall, which is also known as the shear wall. When RC concrete wall or a shear wall are designed and constructed properly, then they will have the strength and stiffness to resist the horizontal forces, and it prevents the rotation of the joints. This is the important specifically in high-rise buildings subject to lateral load, wind, and seismic forces. So the shear wall is nothing but the reinforced concrete wall, which is widely used for hooking to the high-rise building to provide the lateral strength, stiffness, and energy dissipation capacity required to resist the lateral loads arising from the wind or earthquake. It is also important to retrofit itself an existing RC wall, which includes the repair. It also includes the rehabilitation. It also includes the strengthening term also. So if we go for the rehabilitation and the strengthening terms, which is used when the performance of the existing wall does not satisfy the existing requirement of the design course, needs to be enhanced. While the term strengthening is used when the wall was not subjected to any damage, and we have to go apply the high strength. While the term rehabilitation is used when the wall has already been damaged and its resistance needs to be restored and improved as well. If the damaged wall's performance was satisfying before the damage occurred and it is needed to restore its capacity without any additional resistance, then the term repair will be as a representative, as shown in the images, the use of a shear wall as a retrofitting technique. One of the way is to use the infill wall as a retrofitting technique, which has been used in the 2001 during the Bhuj earthquake for an open ground story building. As open ground story building is more susceptible for the earthquake, so here the open ground story can be avoided by providing the infill wall, so that the whole building will act as together and it will not attract more earthquake forces at that particular place. Now let us go with the next terminology, that is rehabilitation. Restoring the structure from a damaged conditions to the functional conditions can be termed as rehabilitation, which includes what? The first is the assessment, the damage, determination of the feasibility of repair. Then we have to decide the best method which is to be required for a repair, preparation for the scheme for the reconstruction, and finally prepare a scheme for propping and bracings, include the schemes of the proper loads. So by strengthening means of reinforcement, strengthening by means of external pre-stressing, strengthening by externally bonded steel plates. Now some of the typical examples where the repairs and the rehabilitations are required, you just see in the one of the images that there will be roots of the trees will be affected over here at a joint of beam and slab, which will weaken the places and the cracks will be there. So here the specific strategy we have to apply for the repairs. Another example here clearly shows a long horizontal crack shown over here clearly because of the deflection of the slab and lifting of the edge of the slab, combined with the horizontal movement in the slab due to shrinkage. This requires a rehabilitation strategy so that we can maintain the same strength as the previous one. This is nothing but the opening of the doors or windows, right? That will be a crack can be visualized. So these cracks are due to pull exerted on the wall by slab because of the drying shrinkage and thermal contraction. This pull results in the bending of the wall, which causes cracking at a weaker section, that is at the lintel or sill level of the window opening. Such cracks generally occurs when the windows and the room spans are very large. These cracks can be avoided by providing slip joints at the slab supports on the wall. This is one of the typical kind of the things can be visualized in the older structure because of the higher silt contained in the plastering work. Yes, inclined cracks, which is can be visualized because of the longer opening and the less bearing due to the lintel load carrying capacity, which expose the diagonal cracks, which is require a specific rehabilitation technique. Vertical cracks as well as the horizontal cracks combines over here under the window when the wall have a larger window opening and little wall space on both the side of the opening. So here the difference in stress due to more stress in the wall portion adjoining to the window and the less stress portion under the seal of the window resulted in crack. Definitely the reinforcement has been visualized over here. So there are certain techniques can be used to provide the repairs and rehabilitation strategy. Finally, I'm winding over here. Thank you very much. Questions are to be welcomed if it is any. If there are no questions, no questions any. So let me run it out.
If you have any question, you can write in the chat. Participants.
One question which has been raised by Dr. Praveen Singhai sir, how much of the retrofitting will cost? It depends upon the type of the strategy which will be adopted for a particular situation. It depends on the type of the defects or type of the things which has been occurred, the type of which retrofitting technique we are going to adopt. It depends on the things. Any other questions? The grouting material is used for the gap filling or increase the strength and durable also. Grouting can be used, first one, maybe as a gap filling, yes, definitely. In certain cases, when there will be a good bond, see, grouting doesn't increase the strength, but the good bond will increase the strength. So definitely it will increase the strength if there will be a good bond will be there. There are so many historical buildings has been adopted the various retrofitting technique. There are so many historical buildings. Yes, I haven't placed any slides over here, but there are so many historical buildings retrofitted. Jacketing. How is the jacketing work? Jacketing enhances the, first of all, if we are using, let example, reinforced concrete jacketing. When you are applying an RC jacketing, you are applying additional steel. Also, you are applying additional concreting. So effectively, you are increasing your cross sections. Means when you are designing for any kind of the cross section, maybe a beam, maybe a column, your reinforcement and the concrete will contribute to the strength. Finally, through the jacketing, you are increasing the cross section. You are providing more reinforcement. You are providing the more what can I say, concrete. Definitely the strength will be increases. For that, our simplest IF 456 formula can be implemented to find out the increase in the strength. Can jacketing of joint be done for existing building without causing serious damage? Definitely can be done. There are lots of researches which has been done, and also the practices has to be carried out without affecting serious effect to the existing structure, and jacketing can be done. Definitely it has been done. And on the FRP, if you are doing proper FRP, you can do the things very easily. Yes, sir, Dr. Praveen sir, there are good firms definitely available in the market for the grouting. In jacketing, how to fill top junction of column and beam. First of all, as shown in the videos, also in the photos, the column and beam joint, that is the junction, is definitely an important term. If you are going for the reinforced concrete, particularly as a retrofitting technique, as a jacketing technique, then as has been stated, that the column reinforcement go from throughout the slab, and beam reinforcement are interconnected between the column and beam, so that they will behave as act as a one, and then the final concreting which has to be carried out, instead of carrying out the jacketing individual as a column. Next question. As far as the cost of the structure is concerned, is there any criteria up to which the strengthening of the structure is possible? Like if the cost of the structure is more than this much percentage of the cost of structure is to be demolished and the reconstruction is done, then as far the structural engineering concerned, there will be a different provision given by certain local authority. I can say the example, the damage type. If I can say the damage type 1, 2, 3, 4, and 5, which has been enlisted over here in this local region. If when during the visual inspection and during carried out certain NDT test, if they feel that it it is under the criteria number 5, then instead of going to carry out any kind of the retrofitting technique, you have to go for the demolish the structure and reconstruction can be carried out. But if it has been carried out the criteria number 4, damage type number 4, then the specific type of the retrofitting technique which has to be adopted. So this kind of strategy which has been given, as far as the Gujarat region is given, this kind of strategy which has been given by Road and Building Department itself. Is there any questions? I think there is no questions in the chat box which can be visualized over here. Once again, I am waiting for the response if any questions is there. Okay, no
Thank you, sir.
questions.
Yes, I think that was all of those questions. If anyone has any more questions, they can write in the chat box.
No questions.
Thank you, sir, for this amazing seminar. Now we'll take a break and then we'll start the third session at 3:30. Thank you.
Thank you very much. Now we are going to take the session start at the 3:30. Just we will take a break.